Okay, welcome back to the drive-through, everyone. We're going to have a little interactive discussion on derivatives. Okay, the limit process for finding the derivatives, and then derivative rules. And this is essentially to go on with the beginning of Unit 2, okay? So even if you're in Unit 2, I do think this is in your best interest to pay a little attention to this. We also are going to go out of order, because many of you already know the rules. What you're not going to remember or maybe understand is how to use the limit process to do it. You'll only be asked to do that one time on your test. So it's not that big of a deal. I survived calculus without knowing anything about the limit process. I just got that question wrong and moved on. Or back then, my teacher might not even have asked me that question. Okay? So does anybody know what the derivative tells you? Yeah, Luca?
The slope
So good.
of any given point.
Okay, the slope of what at any given point? You hit two of the three key words. What kind of lines are we taking the slopes of? Carson?
Functions.
Yeah, this is a function that I have up there. But this function doesn't have slope because it's perpetually changing directions.
Non-linear or something?
Well, what we're finding, anybody know what kind of line that is if I drew it? Yeah. The slope of a tangent line, Alex is back. The slope of a tangent line at any position. I tried to wait for you to do this, but I just didn't know.
It's okay, I think
Well, now just pick up where we just started, okay? So let's talk about the slope of this purple line. What does it look positive?
Yeah.
Does it look like it's more than one?
Yeah.
I agree, okay? This is gonna end up being like the whole, there's a whole unit in calculus for this. What does the slope of that line look like?
0.
It's 0. Notice there's a maximum there. Sorry, there's a minimum there. That's going to end up being super important. And then my last question I have for you is, which one of those lines appears to have the greater slope? Line A or line B? Line B. So it is changing. It's growing quicker. Okay, all right. So now, what if I changed this y? Oops, don't do that. To f of x. Notice nothing happens, okay? So first thing, we need to remember that y and f of x mean the same thing. They're functions. To find does anybody remember the derivative of this? 2x to the first, right? So we already know that the derivative, which is written as f prime of x equals 2x, okay? So now, stay with me while I try to teach you a history lesson. This is how they figured out that rule, okay? So we're going to take some point on the graph, x, comma, y. But instead of y, we're going to call it f of x. And then we're going to add something to that point. And we're going to call that delta x. Okay, we're not going to declare how much we're adding. And then that gives us a new point. So this is x plus delta x, comma, f of x plus delta x. Okay? I highly recommend you pause the video if you're getting intimidated and just look at what we've done. We've taken up any point, x, comma, y. We've added a little bit to it, and then we put that back in our function, and that gave us a new point. Okay, now what if I just wrote this? F of x plus delta x minus f of x over x plus delta x minus x. Does that ring a bell for anybody? Does that look like anything?
Yeah.
Yeah.
It's y2 minus y1 over x2 minus x1. What is that? That is the slope between these two lines. Now, is that a tangent line that I just drew? It's not. It's a secant line because it has 2 points on the graph. But what if I took the limit as delta x approached 0? So if I kept taking this little space down here and shrinking it and shrinking it and shrinking it, well then when delta x became 0, that secant line would become a what? It would become a tangent line. So watch me do this. So f of x is x squared. So we're going to take the limit. I need more room. So we're going to take the limit as delta x approaches 0 of, okay, so f of x is x squared. So we need to do x plus delta x squared. That's f of x plus delta x. I took out the x and I put in the x plus delta x. Remember, this point here is x plus delta x, comma, f of x plus delta x. And this is x, comma, f of x. So what have I done? I took out the x and I put in x plus delta x. And now that is f of x plus delta x. Now I'm going to subtract out our function. What's our function? F of x equals what? Just read it. X squared. So now I'm just subtracting x squared. This is y2 minus y1 in our function. And then on the bottom, I get x plus delta x minus x. And what is that? That's just delta x. So I still can't put in 0 for my delta x because I have a delta x on the bottom. So let's do the math. I'm going to have x plus delta x times x plus delta x minus x squared all over delta x, right? Now I got to FOIL. Let's FOIL without having to write it twice. So let's do this all in one step. What are we going to get when we FOIL this? X squared
plus 2 delta x, or 2x
plus 2x delta x
plus delta x squared.
plus delta x squared. And then I got to subtract this x squared from here. All over delta x. Okay. Let me pause this real quick. I got to erase. Okay, I didn't exactly mean to erase everything, but we're good. We got more space. I just wrote down what we just had. What do you notice about the top?
It has 2.
That's gone, right? So now we have 2x delta x plus delta x squared all over delta x. And now I can factor out a delta x, or you can just say this. Delta x divided by delta x is 1. Delta x squared divided by delta x is delta x. So now we are looking for the limit as delta x approaches 0 of 2x plus delta x. Now can I put in 0 for my delta x?
Yes.
And what do you get? And what was 2x? We already figured out 2x is the derivative. And that's where that rule comes from. Now, higher level mathematicians would call this x to the n, and there would be this really, really long written out proof, and all of the x to the n's would cancel, and you'd end up getting the derivative. If f of x is x to the n, then what's the derivative of that? What is the power rule? N times x to the n minus 1. There's a proof for that, and the proof is just the limit process. Got it? So then the next thing we'll start doing is you guys are going to learn these derivative rules, and you won't have to do that long way anymore. You just use the rules to find the derivative. Once you learn the rules, I'm going to start helping you with find the equation of the tangent line at the given point, and all these other problems that are going to be coming your way. Sound good? All right, thank you. I'm thinking 13 inches of snow. That's my call right now. Calling it on January 21st. On January 24th, it's going to snow 13 inches. Oh!